Hi. The goal of video 3 is to discuss while loops and how we would accomplish that in LabVIEW, which is slightly different than we would in a typical programming language. If you're unfamiliar and you need a refresher on what a while loop is, the general idea is that it will run continuously until some Boolean becomes false, at least in terms of, let's say, MATLAB. If I were to write in MATLAB, x equals 1, while x is less than 3, x equals x plus 1. And what is happening here is that x starts at 1. It comes into this loop. It says, while this is true, keep looping. So x will be increased by 1. Come back up. 2 is less than 3. We'll go again. X becomes 3. We come back up. Is 3 less than 3? Nope, that's false. We will then end the loop and then come down to here. In LabVIEW, it's a little bit different. In LabVIEW, you can choose what your Boolean should be. So instead of saying it will run until it becomes false, you can do it the other way. And that's actually the default way in LabVIEW, and we'll discuss what that looks like. But the general idea of a while loop is that, or how we implement it, is we'll right-click in the block diagram like we've been doing thus far, and we'll go to structures, which is where most of our programming language stuff is. So example, for loops are here, while loops, case structures are like if statements, and there's a few other things here. So we'll click while loop, and when we do that, we'll be able to draw some sort of rectangle. And this is our while loop, this thing here. And it looks kind of confusing, like what does this mean? So based on what we discussed in the past, I want to look at the help file for this. So I can come here and click the question mark, or I can do Control H as a shortcut and it'll just pop up. And I'll come over and I'll highlight it. And you'll see that for this type of structure, it says that a while loop repeats the code within its subdiagram until a specific condition occurs. A while loop always executes at least one time. That doesn't really give us a lot of information of how to actually use it in the sense of what's this lower left and lower right icon. What are they doing? What's their purpose? So let's click detailed help and we'll go through it together. If you do that, you'll see that what we just saw in the smaller help menu is there, but let's come down and look at the component. So it says that number 1, which is pointing to the outer perimeter, it contains the code that the while loop executes once per iteration. So this code here that's in here is what is inside the while loop. Everything on the outside is not repeating. The second thing is the iteration terminal, which will tell us how many times the while loop has run. So basically, if we were to run this 3 times, the final value of I would be 3. And it would just keep incrementing by 1 for every iteration of the loop. And lastly, the most important thing is the conditional terminal. This is what will determine if the while loop is going to stop or not. And let's discuss that for a little bit. So right now it says, evaluate a Boolean input value to determine whether to continue executing the while loop or not. To specify whether the loop stops for a true or false value, you can configure the continuation behavior of the loop. So if we come to here and I come and right-click over here, you see that it says stop if true or continue if true. This is basically the Boolean that allows the while loop to continue repeating itself. So right now it's set to stop if true. That is the default, and that's what I want to work with, which is a little bit different than how we thought of it in the past, especially if you've taken MATLAB with me. Well, let's go ahead and try to understand what's happening here. Let's run a very simple loop. Let's say that we're going to keep looping it, and we're just going to look at how many times it runs. So in order to look at how many times it runs, I want to create an indicator that will show the value of I. So if I were to come to this terminal here, I can right-click and click Create Indicator. Or if I want, I can do it again in the front panel, come to Numeric, Indicator, and I'll drop that down somewhere. Here it is. And I'll wire that to there. Not super pretty, my wires, but it doesn't matter. So this is going to count how many times it runs. And now I also need something to stop this. So let's say I create a control, because that's what I'm going to do. I'm going to tell it to stop. I'll control how long it keeps going for. So I'll create a control, and it comes up by default as a stop button, where currently this button is not suppressed. It's saying don't stop, which means it's currently on false. And again, if you right click this, you see stop if true. So once I click the button, it becomes true. It turns on the button. Then it'll stop. So all this is doing, and this is a perfectly fine code, is that it will just start counting up how many times the loop runs. We'll see that here. And once I click stop, it will go ahead and stop it. So let's run this. I'm going to make this a little bit bigger because it's going to go really quickly. It's already run in that split second millions of times. It's crazy. That's so fast. If we run it again, it just immediately jumps up. It's very quick. There's nothing happening inside of here that's really taking up any time. It's just constantly looping. Maybe we want to slow it down a bit. So this is where a new concept comes in that we'll call timing. There are instances where maybe you want to slow down how fast your code is running for some reason. Maybe you want the entirety of the loop to sample at a certain rate, for example. So we'll slow it down using what's called a wait function. So we come to, if we right click and see some of our options here, we can go to timing. You see that there's this command wait milliseconds, which I can put anywhere inside the loop. Again, it'll be a part of this loop now. And you see that the input of this is milliseconds to wait. The output says what the value is, but I don't really care about that. I just want to see how long to wait. So maybe I'll create a constant and say, you know what, let's wait 1,000 milliseconds, which is 1 second. So now if I run this, this will run, and there's a lot of intricacies with this, but in general, assuming that everything else runs faster than this will ensure that the loop takes exactly 1 second before it progresses to the next iteration. So if we run this, you'll see now that this numeric is not going to millions right away. We are pausing for a second. 6, 7, 8, those are seconds. And once I click the stop, this will become true and cause this to end. So if I click stop, it had to wait for that extra iteration because of the millisecond counter waiter. But again, if we right click it, you see stop if true. So once I suppress the button, that caused it to become true. Hoping that makes sense. Let's do something a little bit different. Let's say that we want this to run for a certain amount of iterations. I'll still leave the wait thing here. Maybe the number of iterations, and I'll change this to say number of iterations. Maybe I want that to run for 5 iterations. So how do you think I would do that based on what we talked about in our last video? Well, if I were to come and compare that value to a constant, I can then determine if it's run for that correct amount of cycles. So let's go to comparison. And I'm going to check if the number of iterations is greater than some constant. So if we do Control H on this, we see that the greater than, we put our X, which we're checking if it's greater than Y. And if it is, the output will be true. And this currently says to stop if true. So what we'll do is take our number of iterations, which again is with this blue wire, and feed it directly into X. And maybe we'll run this for 5 iterations. And then take the output, which is a Boolean. It's either true or false. Is this number greater than 5? True. Okay, we'll feed that to here. We'll go ahead and count the number of iterations. And then it'll go for that amount of time. So based on the fact that I have a millisecond or 1,000 milliseconds, 1 full second, it'll run for 5 seconds. So let's go ahead and run this. We did 1 iteration, 2, 3, 4, 5, 6. It's actually 6 seconds because 6 is greater than 5, not greater than or equal to. So once it becomes true, which the first value, if we're incrementing by 1, will be 6. That's the first time this is true. It's greater than 5. This will become true, and then the loop will stop. So let's go look through this one more time slowly. We have this iteration counter. We're displaying that here in the front panel. You see if I double click this, it pops up over there. And then we're comparing that to some constant. I said I want this to run until it surpasses 5 iterations. And once it does, this output will be true. And then it will stop the code, which is, very useful for us. So that's an example. I want to do a more interesting example. I'm going to delete some of this stuff. So I'm going to delete that. And I'll move this back over here. Move this back. Oops. See how I clicked that there? That switched the condition from stop if true to continue if true. But let's go ahead and say we want to execute something like what I have before. And I'm going to run it infinitely. So in MATLAB, if we have while 1, that means to run it forever until you break out of the code. Let's say I do something like this. Maybe I'll start with the value of x is equal to 0. And we'll add 1 to it. I'll say if x is greater than 5, which is what we just had before, we'll break. Kind of similar to what we just had before. So just looking at this code, x starts at 0. We'll come into this loop, which doesn't know when to stop. It'll just keep running until this break is seen. So x will start at 0. X equals x plus 1. It'll go to 1, 2, 3, 4, 5. Is 5 greater than 5? No. We'll add x one more time to make it 6, and then it'll break. So let's go ahead and try to code something like that in LabVIEW. So we see that we have some operation here, x is equal to x plus 1. So let's go ahead and include an addition here. And I know I'm going to add 1 to this every time based on this. I'll lower the front panel a little bit so we can see this simultaneously. So we want to add 1 to some value of x. And then we want to reuse the new value of x for the next iteration. So what that means is that the output is going to be fed back to the input. Let me explain that more in detail. So when we start this, we're at 0. We haven't specified that in LabVIEW, but let's just focus on this. X is equal to 0 plus 1. That's the first iteration of this code when x is 0, which means that x is now 1. We come back up, and then we'll go ahead and say that x is equal to the new value of x, which is 1, plus that constant. Now x becomes 2. X equal to 2 plus 1. X becomes 3, and so on. X becomes 4. We'll just do it for completeness. X becomes 5. And then on the last iteration, we see that x becomes 6. And then once x becomes 6, it breaks out. So this idea of using the previous value is what we're doing in this loop. This is what we would call a feedback loop, where we're taking the output and using it again as an input. Now, if we do Control H, because something else popped up when I did this, if we highlight this, it'll say this stores data from one VI execution or loop iteration to the next. So it's a feedback node is what it's called. Let's go ahead and look at detailed help. It says something about controls we're not going to worry about. But it says the feedback node uses the value wired to the initializer terminal. What is that? As the initial value for the first block diagram execution, and ultimately it will just repeat after that. So if you come and look, and we click initializer terminal, we'll see that this little star is what's under here, and we can come and look in the, oops, let me undo that. Come over here and highlight on it, it says initializer terminal. That's basically saying what is the original value of x? what is the first value going to be that we add to 1? And in our example, I said, let's make that 0. Right? X is 0, then it'll loop. So this is constantly being added together. 1 plus 0 is 1, then it loops around, and then it goes through the 1 to add to the constant to create 2. That 2 goes backwards. 2 plus 1 is 3, and it just keeps looping and looping and looping. That's essentially what is happening with this x equals x plus 1. Now we want to see if x plus 1 ever goes past 5. So let's go ahead and again do some sort of comparison thing. Let's do greater than. That output, is it greater than 5? If it is, well, that's when the loop is going to stop. And currently, we don't have anything showing in the front panel. There's no indication as to what any of these numbers are. So at this point, I'm going to try to include another interesting thing about while loops, in that outside of the while loop, you won't see any values until the while loop is then executing, just like in MATLAB. If I were to do this in MATLAB, I'll never see the 1, 2, 3, 4, 5. I won't ever see that. I'll just see the final value. This is outside of the loop. While if I did something like this, maybe here, if I did something like that, this will display on each iteration of the while loop. So let's see if we can accomplish that by showing the outside stuff and the inside sum at the same time. So what I'm going to do is I'm going to create an indicator here. Again, indicators show us things, and I'll say the sum during the loop. And whenever we're adding 1, I want to look at that. So I'll go ahead and plug that into here, the sum during the loop. So again, we do 0 plus 1. That 1 will be displayed here. We're following the wires. And simultaneously, that 1 is being checked against the 5. If 1 is greater than 5, then that would end up determining if the while loop continues. Is 1 greater than 5? No, it's false. So this is false, which means we're not stopping yet. Again, because we have stop if true. So that's what's going to be happening during this loop. Now, if I run this, it's going to happen immediately. It just went to 6. So let's do another wait timer in here so we can visualize this. Wait. And I'll wait for, let's say, a second again. So if we run this, we'll see that the sum during the loop is 1, 2, and it's going up. It's just constantly moving. And then once it gets to 6, it will display that 6. But that 6 is also being compared to the 5. It's greater than. That becomes true. We stop the loop. So how do we see our final value? Well, what we want to do is what's called tunneling, where we build a tunnel through the loop to the outside world. So I'm going to grab our data, our sum, and bring it to the tunnel. You see that there's a little dot that's being created right now. If I click, or double click rather, oops. You see that I've made this orange dot show up, which basically gives us access to that information. But the thing is, the way that it's set up, and we may or may not talk about how to change this value, is that this value will not feed forward until the loop is done. Oop, I don't want control. I want an indicator. Let's do create indicator. This would be the sum after the loop. So if we run this, this will never change while the loop is progressing. But once the loop is done, then we'll go ahead and see what the value is. So let's go ahead and run this now. If we run this, you'll see that this is changing. This is not changing. But once it gets to 6, it says 6 is greater than 5. It's displayed here. We checked. This has to finish its wait. Once it's done, it'll come out, tunnel through, and then show that final value. Let's do that one more time so we can see it. Note that maybe I'll just go ahead and stop this. Let's come to here and make this 0. Run this again. It's summing, it's summing, it's summing. It gets a 6, it has to wait a second, or whatever amount of time is left that took. It might have taken, a nanosecond or something crazy. I'm exaggerating. I don't know how much it actually took. But it ultimately needs to wait a total of a second before any values here come out. And that's the idea of a while loop. If we do Control U, and again, if you come to Edit and do Control U, that cleans up the diagram. You can simplify this a little bit to make it more clean. But that is what is happening inside of this while loop. I hope that makes sense. If you have any questions about while loops, let me know. We'll see this when we start building VIs in the lab, that while loops exist, and I want you to have an understanding of what is happening with them. So I hope that this was a good introduction. If you have any questions, again, let me know. Otherwise, I'll talk to you soon. Thanks.